All right, I picked a few on the back of this page to do for you to show you some different ways that it could be seen. Number 7 says an 8-kilogram car. That's my mass. Traveling at 5 meters per second. This is my initial velocity. Calculate the final speed. So we need my final velocity of the cart if it has 300 joules of work were being done. So my work is going to be 300 joules. This is also equal to my change in kinetic energy. Because our work is equal to our change in energy. And we can set up our equation. So since we weren't given a force or a distance, we can just say our work is going to be equal to our final minus our initial kinetic energies. And if I want my final velocity by itself, this is a little jarring to look at when it gets rearranged. So I'm just going to plug in the numbers and then do the rearranging once we have the numbers in. So my change in energy is going to be 300 joules. My mass is 8. We're looking for our final velocity. And we have an initial velocity of 5 meters per second. So 25 times 4 gives me 100. 1/2 of 8 is 4. So I have 300 is equal to 4v squared minus 100. And I'm going to add 100 to both sides, leaving me 400 is equal to 4v squared. Divide both sides by 4. That gives me 100 is equal to v final squared. I need to square root both sides because my v is squared in the equation. So my final velocity is going to be 10 meters per second squared. Let's do another one. Number 8, it's got a 24 kilogram go-kart. This is my mass. And it's got an initial velocity of 10 meters per second. The engine exerts a 50 Newton force. To accelerate the car over a distance of 30 meters. So these are our variables. What amount of work was done by the engine? What's the final kinetic energy? And what will the cart's final speed be? So we have our work is equal to our change in kinetic energy. The part A asks the work done by the engine. So work, force times displacement. Our force here is going to be 50 times our distance of 30. We got 1,500 joules of energy is the work being done by the engine. Part B says, what's the final kinetic energy? So if my work is equal to my final kinetic energy, minus my initial kinetic energy, we can figure out what my final kinetic energy is by plugging in our variables. So our work is going to be equal to our final kinetic energy minus our initial kinetic energy, which we have mass and velocity for. So we are going to expand that part of our equation. And then when I rearrange my equation, I'm going to add the 1/2 mv squared to both sides to get my kinetic energy by my final kinetic energy by itself. So my work plus the initial kinetic energy is going to give me my final kinetic energy. In this case, my work done. We figured it out in the first part. It's 1500 plus my initial kinetic energy. So let's see, what is this? 100, so 50 times 24. So got 1500 plus 1200 is equal to my final kinetic energy, 2700 joules is my final kinetic energy. And of course, you don't have to show so much work as this. Right, I would just expect that you show part of this as long as you are following along. And I can follow along your work, more importantly. So, well, that's not more important. It's of equal importance. Anyway, for part C, it says, what is the car's final speed? The final speed of the car we can figure out with our final kinetic energy is equal to 1/2 my final velocity squared. We have this, we're looking for this. So when I rearrange my equation, it's going to be 2ke divided by m square root, because my velocity in the equation is squared. So 2 times 2700 divided by my mass gives me, I don't know, it's better. I knew that was too big. I need to square root it. Okay, 15. I was gonna say it was 225, but that didn't seem right because we started with an initial velocity of 10. So I knew something was wrong, and which made me take the square root, which is the last thing that you should be doing.